Section 8.4 is multiplying special cases. I can find the square of a binomial, and I can find the product of a sum and difference. Big ideas here. There are special rules for simplifying the square of a binomial or the product of a sum and a binomial. Take note here on page 405, talks about the square of a binomial. Here, I have a plus b squared. What that means is we're going to take away our squared and write it as the product of a plus b. When we do that, guys, we take firsts, a squared, outsides is a times b, and insides is b times a. So when we combine those, we always end up with twice that outside and inside product. And then we take b squared here. So every single time, it's going to set up to be this pattern. Same thing here with a minus b squared. We could write it as a minus b. Remember, we have to take our entire base times itself. Firsts, outsides is negative ab. My insides is negative b times a, which is also negative ab. Last, negative times a negative gives me a positive b squared, which we have here. So when I can combine those like terms, I get my middle term there. Because my outsides and insides are always going to be exactly the same thing. So we can use this as kind of a shortcut. We can take, when we have a plus b squared, I can take a and square it. I can take b and square it. I can multiply a times b together and take it times 2. In example 1 here, we are squaring a binomial, so the simpler form of each product. We can still write this out and do it like I did on the last slide when I was showing you the take notes there, or we can use our shortcut. I can take x squared, and I can take 8 squared. I can multiply them together, 8x, and we have to double it because it's our outsides and our insides, which is 16x. That was a positive 64. So here we go. It just saves us that time from writing it out and then foiling. We combine our like terms. We get to the exact same place as if we used our shortcut. On b, same thing here. I can take 2m and square it. And when I do that, guys, remember we square the entire thing, so I actually get 4m squared. I take negative 3 and square it, which is positive 9. I multiply them together, negative 6m, and double it, negative 12m. So here I get 4m squared minus 12m plus 9. And if we'd have done it like over there, we'd have gotten to the same thing, just not quite as quickly. But if you're doing this and you're like, gosh, I can't remember what the pattern is, I can't remember what I need to do here, things like that, you can still write it as the binomial times the binomial for the basis. Now, feel free to pause here and give this a try if you'd like. So because we have a binomial squared, we can use our shortcut. We can take our first term, square it, our last term, square it. So when I take negative 7 times itself, I get positive 49. We can multiply them together, negative 7n, and double it. So here I get n squared minus 14n plus 49. Same thing for b. 2x squared, remember we square both pieces there. So I end up with 4x squared. My last term, square it, positive 81. And that's because here, if I were to write them out, both of my firsts would be the same, both of my lasts would be the same. So I can square those right away. I multiply the 2 together. 2 times 9 is 18x, and double it. And again, that's because our outsides and insides are going to be the same, So when we combine the exact same thing, we have twice as much. In example 2, we're applying the squares of binomials. A square outdoor patio is surrounded by a brick walkway as shown on page 505. I have kind of a sketch of it here, at least a rough drawing. What is the area of the walkway? So here we are looking for the area of the walkway, which is just this in black here. So in order to do that, we need to find the whole area and then take away our patio. So we need our side lengths here of our big square. If this is x, and this is 3, and this is 3, then we have 3 plus x plus 3 for each side, so x plus 6. Same here, okay? This distance is 3, this is x, and this is 3. So we have 3 plus x plus 3, which is x plus 6. So my entire black square would be x plus 6 times itself, or squared. So I take firsts squared, my last squared, multiply them together, 6x, and double it, 12x. But we're not looking for the entire area. We're looking for just the walkway, which means, again, we're taking out this gray part. The area of that here, we have x times x, so x squared. And since we're taking that part out to just get our walkway, we're going to subtract there. So we'll combine our like terms. X squared minus x squared is 0x squared. So I have 12x plus 36. And this is feet squared. Now, suppose the walkway in example 2 is 4 feet wide. What is its area? So, same idea here. We need the entire area. So, area of the big square. And we're going to subtract out the area of the actual patio. So, area of our little square. Here, my side lengths, I have 4 plus x all the way across plus 4. So my length on each side is x plus 8. Same thing here, 4 plus x plus 4, x plus 8. So to find the area of my outside square, I take my side and square it. To find the area of the inside square, I take my side, here x, times itself, or squared. Okay, we can either do length times width, or we can do side squared. X squared is just x squared, but when I square my binomial, I have to square the entire thing. So I take my first term squared, my last term squared, I multiply the two terms together, 8x, and double it, 16x. I'm going to bring down my minus x squared. I'm going to combine like terms here. X squared minus x squared is 0x squared. So I have 16x plus 64. And this is still in square feet because we're talking about area. In example 3, we're going to use mental math. And when it says use mental math, guys, it's not saying you can't write anything down. It's not saying that you can't still show your steps. What it's saying is we don't want to do this. We don't want to take 39 times 39. Okay, we're not trying to do that. We're also not just typing it in our calculator. We're coming up with an easier way to do it with just what we know in our noggins. So what I really have here is 39 times 39. Base times itself. So we're going to look, 39 is close to 40. It's a number that ends in a 0, and multiplying by 4 is a lot easier than multiplying by 39. But to get from 40 back to 39, I have to subtract 1. So I'm looking for something that I can rewrite 39 as that makes it a little bit easier to work with. And I can take 39 as 40 minus 1, and it means the same thing. Now again, we're still squaring it, so we're still taking it times itself. But by doing it this way, I can take 40 squared, 4 squared is 16, and we have the 2 zeros, 1 for each term. I can take 1 squared, which is just 1. I can multiply the 2 together, negative 40, and double it. Now I can take 1600 minus 80, 1520. It's like if you have $16 and subtract 80 cents, you would still have $15 and you'd have 20 cents. And then we'd add the 1 and get 1521. So here we broke it down into a lot easier pieces to work with rather than if we were going to take 39 times 39. It's very helpful anytime we're trying to do things and we don't have a calculator, or we're trying to just double check or kind of in our heads see if our answer seems reasonable. It's also how I do a lot of things in class where sometimes people think it's magic. Nope, it's just properties like this. Now, feel free to pause here and give this a try if you'd like. We want to know, what is 85 squared? So 85 is right in between 80 and 90, so it doesn't matter which way you go. We can either go to 90 or go to 80. I'm better at adding than I am subtracting, so I'm going to go to 80 plus 5. Again, if you wanted to do 90 minus 5, you could. What we're really looking for, guys, is to take it to the closest number that ends in zeros. Because if we can multiply with 8s instead of 85s, or with 9s instead of 95s, it's a little bit easier. So 80 plus 5 is the exact same thing as 85. So we're just rewriting 85 in another way. Here I'm going to take my firsts and square it. Well, 8 squared is 64. And I have a 0 from each factor, so I have 2 zeros in my answer. 5 squared is 25. I'm going to multiply them together. 5 times 8 is 40, and again, we have that extra 0. And double it, which is 800. Now when I add these up, 64 plus 8, 7200. Plus 25 is going to give me 7225. And that's what we get if we took 85 and squared it. And again, using mental math doesn't mean that you can't still write your steps. What they're saying is at no point did I have to reach for a calculator. At no point did I have to carry the 2 and go about it like long multiplication way. Okay, we're trying to do this. If we didn't have pen and paper, we could at least kind of go through these steps, or without a calculator. And I'm going to stop here, and I'll continue on this section in the next video.